Up next, last week we told you about a new company. It's called Ingenious Ag that's located at Nebraska Innovation Campus. University of Nebraska-Lincoln professor and co-founder Dr. James Schnabel, he is leading that venture. He had a conversation with the Dean of Ag Research, Derek McLean, about their efforts. During their conversation, the two discussed how the facilities located at Nebraska Innovation Campus, how they're a great springboard into creating new ag tech, as well as the next generation of ag researchers. Here's their conversation.
One thing about facilities I'd like to talk about is where we're sitting today. We're at the Greenhouse Innovation Center on the Nebraska Innovation Campus.
Yeah.
And behind us is actually a piece of equipment, a very complicated piece of equipment that is collecting data as we speak. So could you give us a little bit of information about what's going on behind us and what this system is doing and what it can measure?
So this is the automated phenotyping greenhouse here at the Greenhouse Innovation Center. It can grow up to 700 plants and move them through this entire system, measuring the amount of water each plant uses every day, collecting images from 5 different cameras, including an RGB camera that allows us to reconstruct the architecture of plants in 3 dimensions and then translate that into computer models where we simulate how those 3D structures will perform in different fields under different planting geometries and different environments, as well as a hyperspectral camera, which lets us measure the chemical and biochemical composition of plants and how that is changing over time. A lot of the data that we're able to pull out of that hyperspectral camera is actually the result of algorithms developed by my colleague Yufan Ga, who is the director of the Greenhouse Innovation Center, the phenotyping efforts generally here at the University of Nebraska-Lincoln.
So, I mean, this is precision agriculture
Absolutely.
at its best that's helping us understand what are the inputs that plants need. Is that correct?
That is correct. I would say one of the really powerful things about this system is that we're collecting data from plants over and over again in a non-destructive fashion. So a lot of research that looks at how plants respond to different stresses comes out and measures the properties of the plants either at harvest or 1 or 2 times throughout the growing season. With this system, we can monitor the performance of the plants on a day-by-day basis throughout their development. And research here at the University of Nebraska, in my lab and other labs in our statistics department, are developing the tools we need to best leverage this new way of monitoring how plants respond day after day. So one of the things to understand about this system is there are only a handful of these across the US, and the system here at Nebraska is unique in that we can grow corn and sorghum all the way to maturity. We can grow plants 6, 7 feet tall in this system and monitor how a corn plant goes through its entire life cycle. This is a unique capability that only exists here at the University of Nebraska. It's part of what positions us so well to be studying not just basic biology, but understanding how our major crops are going to respond in severe weather events, building towards a more sustainable, more resilient agricultural system that protects our nation's food supply and our state's economy.
Oh, I get it. That's excellent. So what you're really saying is what we're able to do here is we're combining a state-of-the-art greenhouse facility with a state-of-the-art technology, research technology piece that we combine those to grow the plants to full maturity and then be able to take continuous measurements throughout that plant's life cycle. And that's really a benefit then for understanding what are the inputs that are needed for our producers.
Absolutely. We can also use this system as a test bed. In about a week, we'll have an experiment going on this system measuring a new type of sensor that can monitor the amount of water flowing through the stalk of a corn plant in real time. We hope that this will ultimately develop into something that can be a product deployed in the field, helping farmers with center pivot systems to monitor just how fast corn plants are burning through the water in the soil and make better decisions about scheduling irrigation than they currently can. And it's only possible because we have this system that can measure water use in such a precise fashion day after day after day.